Hi guys, welcome to our first video for calculus. The beginning of calculus really starts by talking about limits, and it would probably be helpful if you know what a limit is. So if this is your first time being exposed to limits, it shouldn't be because you should have talked about it in pre-calculus. But if it is, I'll give you a quick review about a limit. So the definition of a limit basically says, as my function gets really close to being plugged in for a particular x value, I want to know what the particular output value is. Now, that can be pretty vague for people who are not mathematicians. So let me start with a graphical approach. Okay, so take a look at this graph. So here I go. So this function is saying as x approaches c. Now that can be any value on the x-axis. They call it c just to be arbitrary, but that could be 2 or -1 or 1,000. Okay, so we want to know as our graph gets closer to this x-axis value, f of x is just telling you the name of the function in case you had more than one. Sometimes it'll actually be an equation. And then it wants to know what the L value is. Now, I think it's important to understand that L is talking about a y value. So that's what we're looking for. Is there a y value? And it has to approach the same thing from either side for this to exist. So let me draw just a general graph. Okay, so here comes my graph as it approaches C on that side, and maybe here comes my graph as it approaches C on this side. Now, this is obviously kind of a crazy graph, but it really doesn't matter because all I really want to look at is what happens as it approaches C. Okay, so let's take a look. So if I ride my graph from the left, I'm approaching that value there, and as I ride from the right, I'm approaching that value there. And they both appear to approach the same output or y value, and that value L would be my limit. So, for example, this c value could be 2 and this y value could be 3. If so, your limit would be 3. But it does have to approach the same thing on either side to have a limit. So, just in contrast, if I had a graph that looked like this, I'm actually going to put a number in and it did that on this side and maybe this on that side. See how those are approaching two different values? Like this guy is going towards maybe that's 3, and this guy from the right is going towards maybe that's 4. This is not going to have a limit as you go towards 2. But we'll talk about that later. It's just a little preview. Okay, so to start off, we're just going to estimate some of these, and we're going to use our calculator for most of it. I'm going to cover that up. Pretend you didn't see that. Okay, so the first one we're going to look at is the limit as x approaches 2 for this function. And we're going to estimate it. Now, in reality, guys, if you want to know what the value is at 2, and this is just a linear graph, that's just a line. There's no breaks or jumps or asymptotes in that graph. That graph is continuous. In theory, you can actually just plug in the number 2 for x and get your value, which is 4. But you don't know a lot about graphs maybe yet and their limits. So for right now, we're looking at estimating them using a table. Okay. So check out this table. This table shows x values as I get closer and closer to 2. So like 1.9, 1.99, you get the idea. We call this coming from the left or coming from below 2. And this guy's coming down from above or from the right. So I get closer and closer to 2. Look at my y values. Yep, they're getting closer and closer to 4, just as we predicted. In example 2, we're looking at as x approaches 0. Now, if I tried what I did earlier and actually plug in 0, let's just take a look because technically that's kind of what I'm doing. All right, so then I get 1 minus 1, I get 0 over 0. Whoa. Dividing by 0 has definitely been an issue for us in the past. And so, we're wondering, but does the fact that it's 0 over 0. Do they cancel out? How does that work? So we're going to talk about that in the future, but for now, we're going to use our table to get a better estimate. So let's look. Here are numbers that are smaller but getting closer to 0. Here are numbers that are bigger but getting closer to 0. Look at those y values. Yep, they both appear to be approaching 2. Okay, so I've given you the table in all the previous examples, but you may not have a table in the future. You may have to come up with that table on your own. So how do you do that? So let's look at this limit. We're finding the limit as x approaches 1 or gets closer to 1 of this rational function. All right, so you're going to take out your calculator. I'll pull mine up. Here we go. And I am going to plug in that value. So Notice I already have that done. But I do want to show you a quick way to put a fraction into your calculator. This might be new for some of you. Um, if you want to go to F1, which is alpha y equals, see that little F1? While you're in the y equals feature already and see this n over d, that's numerator over denominator. If I select that, it gives me a fraction, and then I'm able to plug in, equations there as needed. The reason I find that so nice is I don't have to use parentheses, which can get confusing, and especially when your values and your equations get really large, it can be hard to track where your open and close parentheses is. So there you go, little side note. Okay, so if I wanted to graph this, I could, and there's a vertical asymptote at 1, which is part of the reason we're looking at 1 for this function. Again, getting a little ahead of ourselves. We really just want to look at the table. The problem is if I go to my table and it's a regular table, I'm only going to go by integers. In fact, here, let me change it back to that, and you'll see what I'm talking about. So here I go to my table, second graph, oops, second graph. Okay, I graphed it anyway. So sorry, second table, there we go. And obviously at 1, I have an issue because if I plug 1 in, I get a 0 on the bottom. But if my table's set up this way, I can only see -1 and 1, which aren't really that close, or I'm sorry, 0 and 2, which aren't really that close to 1, right? I need to see things like 0.9999. Okay, so we're going to go to our table setup, which is second window. And I'm going to choose what number I want to look at, which I want to look at 1. And then I'm going to say ask. Now, you don't have to change this to 1. I do. You really just need to change it to ask because it's going to let you plug numbers in. So then go back to your table and look, it's empty. That's because you have to put in what x values you want to look at. So maybe I put in 0.9, which is close to 1, or 0.99, which is getting even closer to 1. You get the idea. I could keep going. I could even go above 1, so maybe 1.001. So I think we can both agree that this is getting closer and closer to 2. So the limit for now, estimating only, is 2. Okay, but if you want a little sneak peek into where we're going with this, we're going to um, solve this by factoring. As you guys can see, I've got an x minus 1 on the bottom, and that's the issue. It's causing me to have a 0 on the top and bottom. If you didn't see that already, let's plug in 1. If I plug in 1, I get 1 minus 1 plus 1 minus 1 over 1 minus 1, which is in fact 0 over 0. This idea means that there must be a factor on top and bottom that's x minus 1. If you didn't follow, let's do it. So on the top, I'm going to factor by grouping. If you remember, factoring by grouping means I'm going to group these two together and factor out what I can, my GCF from both. So I'm going to factor an x squared out of those two, x minus 1. I'm going to factor out just a 1 here because there's no other common factor. And then that's still over x minus 1. Okay. Then on the top, I'm going to take an x minus 1 out of both of these positions. So that gives me x squared plus 1 over x minus 1. Now look what happens. I can cancel those two out, which means that this whole thing basically reduces, so I'm still having the limit as x approaches 1, to just x squared plus 1. Well, that's way easier to plug 1 into. Check it out. 1 squared is 1 plus 1 is 2, which we already got here. But again, all this that I'm doing on the side is a preview of what's coming up next. Just showed it for those who wanted to see it. We'll get into a little bit more during class, and then we'll move forward into some of these ways of finding limits when we have discontinuities. See you in class.